Alright, so today we're going to continue on with packet number 8, and that means that we are now on the next problem, which is number 41. Now for 41, it says that Caroline knows the height and the required volume of a cone-shaped vase that she's designing. Which formula can be used to determine the radius of the vase? So it gives us a few different options, but we know that the volume of a vase is equal to, or a cone, the volume of a cone is 1/3 times pi r squared h. So the question's asking us to solve for r. Alright, so that's what we're looking to do. So let's try to get r by itself. So the first thing we could do is we're multiplying by a few different things, and let's get rid of them by dividing by them. If you are multiplying and you want to get rid of multiplying, we could divide. And if we divide both sides by 1/3 pi h, cancels these out, cancels these out, cancels this. So you wind up with r squared is equal to v over 1/3 pi h. And then that looks a little bit weird because you have a fraction divided by another fraction. 1 divided by 1/3, one way we could get rid of a fraction is multiply the top and bottom by 3. That would give us r squared is equal to 3v, but 1/3 times 3 is just 1. This cleans up our answer a little bit. You just don't want to have a fraction inside of another fraction. It just gets a little sloppy. So the last step we have to do is get rid of our square. So just like dividing is the inverse of multiplying, square rooting is the inverse of squaring. So we would get that the radius is equal to the square root of 3v over pi h. And technically when you take the square root of something, you do get a plus or minus on the other side. But the question is asking us for the radius. Now the radius, or a length, is always positive. So you can see that there's two answer choices in this problem. One, it says that's answer choice D. And the other answer choice, it looks very similar to that. It says r is equal to the square root of 3v over pi h, and that's option B. And then we have another one, so they're really trying to trick us here. Part C, it's saying that r is equal to the square root of 3v over pi h. Now one thing we could get rid of automatically is that we know that the radius is always positive. So it can't be positive or negative. That takes out option D. Now we're down to option B or C. And at this step, we had to take the square root of the whole thing. That's different than just taking the square root of the top. We took the square root of the whole thing, so that can't be the right option. The only option we're left with is option B. Alright, so now let's go to the next one. It looks like we're just solving for different variables here. So for problem number 1 next, it's saying that V is equal to LWH, and we're looking to solve for W. Well, in order to get rid of multiplying by H and multiplying by L, we divide by H and we divide by L. We get that W is equal to V over LH. For problem number 2, it's saying that A is equal to 1/2 BH, and it's asking us to solve for B. Well, looks like we're multiplying by H, we're multiplying by 1/2, so if we divide by 1/2 in H, we would get that B is equal to A divided by 1/2 h. And again, it's a little bit funny to see a fraction in the bottom of a fraction. So let's multiply the top and bottom by 2. And we get that b is equal to 2a over h. For problem number 3, it's saying that s is equal to 2 pi r h. And it's asking us to solve for h. Okay, we're dividing by r, or I'm sorry, we're multiplying by r, we're multiplying by pi, we're multiplying by 2. So let's divide by 2 pi and r to get h by itself. We get that h is equal to s over 2 pi r. Moving to number 4. It's saying that we have ax plus by plus c is equal to 0, and we would like to solve for y. So whenever we're solving, if you remember the acronym PEMDAS, we simplify going this way. But whenever we're asked to solve for something, we go in reverse order. So the first thing we're looking to do for this problem is, could we add or subtract to get the y to be by itself? And the answer is yes. We could subtract ax on both sides. We could also subtract c on both sides. Now the next thing to do, we already added and subtracted. Let's divide both sides by b, and we would get y by itself. Now that's the same thing as writing y is equal to negative ax over b minus c over b. Both of those are exactly the same thing. You should be able to do that. Remember, whenever you're dividing by a number, you have to divide everything on top by that number. Continuing on with this packet, looks like number 39 is our next problem. And for problem number 39, it says that a is a non-zero real number, and a times x minus 3 to the second minus b is equal to c. It's asking us for this first part, prove that x is equal to 3 plus or minus the square root of b plus c divided by a. Really what this is asking us to do is get x by itself. So let's do that first. We'll get x by itself. So we have a times x minus 3 to the second minus b is equal to c. Remember, when we're solving, we go this way. So we want to try to get x by itself. Let's add b on both sides. We get a times x minus 3 squared is equal to b plus c. Next step, once we added or subtracted, we go to multiply or divide. I can divide both sides by a. Remember, the goal is to get x by itself. If we're multiplying by a and we divide, it cancels out. We get x minus 3 to the second is equal to b plus c over a. We saw this in the last problem, that if you want to get rid of squaring something, we take the square root of the whole thing. And we also said that whenever you take the square root of anything, you wind up with a plus or minus, which means we have one more step to do, and we could add 3 to both sides. We would get x is equal to 3 plus or minus the square root of b plus c over a. So as far as what your answer would be, they would check to see all of this work for your answer. Another thing they're saying is if A is equal to 2 and B is 5, determine what conditions on C will restrict the solutions for X to real numbers. Okay, so we know that X is equal to 3 plus or minus, this is that second bullet, the square root of B plus C divided by A. And what it's telling us is A is equal to 2 and B is equal to 5. So I'm going to put those in. Now whenever you have a square root, the only numbers, you could take the square root of anything. You could take the square root of 15, even though it's not going to be pretty. You could take the square root of 4. Square root of 4 is 2. You could take the square root of 9, it's 3. Square root of 1 is 1. Square root of 0 is 0. But you can't take the square root of a negative number. That's what it means by what are the restrictions for this. So this part, the part that's on the inside, 5 plus c over 2, cannot be less than 0. Meaning it has to be greater than or equal to 0. We could take the square root of any number that's greater than or equal to 0. So let's solve for this, and that's going to tell us what c is allowed to be. So 5 plus c, if we want to get rid of dividing by 2, we can multiply both sides by 2, and then subtract 5. Get c is greater than or equal to 5. So as long as c is greater than or equal to 5, everything's good. Now let's just make sure we answered the question. Proved it. We proved it right here. And then for that second piece, determine under what conditions on C will restrict the solutions for X to real numbers. And in order to get real numbers, the inside of your radical has to be greater than or equal to 0. And if you solve for that, C has to be greater than or equal to 5. Moving down to question number 37. Problem number 37, it says that a ball is thrown upwards and its position in the air is determined by negative 16 t squared plus 40t plus 3. What's the meaning of 3 in the expression? Well, if you're throwing a ball upwards, pretend this is you. Right? My drawing leaves a little bit to be desired. Right, so just think about what we're actually drawing. This is when you throw it upwards. This is when time is 0. Maybe this is time is 1. Maybe this is time is 3. This is time is 4. Maybe this is after 5 seconds. So if you think about it that way, if you're throwing a baseball up in the air, well, t is 0 means the height of the ball when you start to throw it. So that option, it says part A, the ball took 3 seconds to reach its maximum height. Well, that doesn't make any sense. When time is 0, negative 16 times 0 squared plus 40 times 0 plus 3, that's the height at time 0. The ball took 3 seconds to reach the ground. No, that doesn't make any sense. And then C, the ball was thrown from a height of 3 feet. Yeah, well, at time is 0, you didn't throw it, right? So you're just getting ready to throw it, and it's 3 feet off the ground. So the answer for this would be C. The height, let me see here. The way that the answer is worded is the ball is thrown from a height of 3 feet. All right. And looks like we have one more problem here. Not going to have enough time to do it today, but we'll be able to finish up this packet tomorrow, and then I'll tell you what the quiz code is. All right, thank you very much. Have a nice day.